In this paper, we study the non-convex matrix recovery problem, which has a variety of applications in machine learning and artificial intelligence, as well as other fields of engineering. The problem is non-convex, so in general, a local search algorithm like stochastic gradient descent may get stuck at a spurious local minimum. This results in failure. There was a similar result from 2016 that, under a so-called restricted isometry property, or simply RIP, that spurious local minima do not exist, and so a local search algorithm is guaranteed to find the globally optimal solution. In practice, the guarantee is actually fairly conservative. To see this, let us use the Frobenius norm to measure the length of a given matrix. In order for the operator A to satisfy RIP with a constant of 1 over 5, it must stretch or shrink the length of a matrix by no more than 10%. This conservatism naturally raises the question, can the threshold be significantly improved? What we're really asking is whether the problem is inherently easy or inherently hard. Many previous authors have attempted to improve the constant, but every proof technique arrived at approximately the same value. In this paper, we give the first conclusive answer to this question. First, we give a counterexample to prove that the threshold cannot be improved past a half. Consider the problem instance to find the matrices shown. Running a stochastic gradient descent, we observe the algorithm getting stuck at a spurious local minimum. Repeating the experiment over 100,000 trials, we find a positive failure rate of 12%. The same example can be generalized to any arbitrary rank 1 ground truth. We actually prove a stronger result in the paper. We prove that given any two vectors x and z that are non-zero and not collinear, we can find an instance of low-rank matrix recovery satisfying RIP with a constant of greater than or equal to a half that has z as the ground truth and x as a spurious local minimum. That is to say, if our problem satisfies RIP but the constant is greater than or equal to a half, then we should not expect to make a global recovery guarantee. But what happens when the constant is less than a half? In the paper, we provide strong evidence that the resulting problem contains no spurious local minima, and in the journal version, we give conclusive proof for the rank 1 case. And this results in the first sharp RIP-based exact recovery guarantee shown here.